right, y'all. So since we took our notes on parallel and perpendicular lines, let's do some practice problems. All right. Let's look at these first two problems here. Let's look at A. So it says graph the given lines and determine if they're parallel, perpendicular, or neither. Okay, so let's look at the first two. Y equals 3x minus 1 and y equals 3x plus 2. So first of all, do we really need to graph them? I don't think so. Because look at their slopes. This slope has a slope of 3, and this one has a slope of 3. So since their slopes are both 3, what can we say? Both have the same slope. So they are parallel. Let's be rebels and not even graph those. All right, the next one, B. You know what? It's the same thing. This has a slope of 1/4, and this one has a slope of 1/4. These have the same slope. So they are parallel. Now, if you want to practice, you can. We can practice. There's -1 up 3, 1, 2, 3 over 1. You can graph that line if you want to. I'm just going to do it real quick. Oh gosh, it's not going to be pretty. It's hard to graph on here. I don't even know if it's going to go in the right spot. Close to it anyway. And then, let's see, it goes to 2. And then from there, 1, 2, 3 over 1. So if we can graph a line. Yeah, it's not going to be pretty there either. All right. There, they look parallel. They're not really. They don't look parallel, but they are parallel because the slopes are the same. All right, so let's look at these next two. Let's look at C. You know, we can't see it right away, so we have to solve for Y. So let's do each one of those. Let's do this one on the left and the other one on the right. All right, so we have X plus 4Y equals a -4. Let's solve for Y and see what kind of slope we have. Let's subtract X from both sides. Now I'm going to come up here and show you what I'm doing here. Subtract X from both sides. This equals 0 over here, so there's nothing left over here, but that's where I got my minus X over here. Okay, and then I divide everything by 4. And I have Y equals, this is a -1, and don't forget there's a 1 in front of here. So that is a -1 over 4x. That's our problem child problem, remember? Let me fix this real quick. It's a negative. Okay, so if I put it in where my slope comes first, then my y-intercept is a -1. My slope is -1 over 4, 2, 3, 4. All right, and I can graph this like so. All right, so there's that line, kind of. All right. And then let's solve this other one for y. I have 4x minus y equals a -2. So I have a -y equals, and I'm going to subtract 4x from both sides. And bring down my -2. Well, y is not by itself because there's a -1 multiplied by it. So if I divide everything by -1, I'm going to have a positive y and a positive 4x and a positive 2. Let me do that for you real quick. I just said that out loud, but I'm going to divide everything by -1. And all it does is it changes the sign of everything, okay? So my slope of this line is a positive 4. So my y-intercept is at 2. My slope is 4, so go up 1, 2, 3, whoops, 1, 2, 3, 4, and over 1. There's no run, so we put a 1. 2, 3, 4. Okay. Y'all heard that big sigh, didn't you? Love technology until it doesn't work like you want it to. All right. And there we go. All right. Now, what do you think about those lines? They are perpendicular. Because look at their slopes. They are negative reciprocals of each other, opposite reciprocals. I flip this negative 1 over 4, not floor. Flip that, and it becomes a positive 4 over 1. There's a 1 under that 4. All right. And then D, oh, look, they're already solved for y. Let's just graph those. So I have y-intercept of 1. From there, I'm going to move using my slope. All right, I'm going to go up 2, 1, 2, and over 1, because I don't have a run. No run, we put a 1. There's that one. And then I have negative 1/2 x plus 4. There's my y-intercept. And I'm going to go down 1 and over 2. So this is a negative 1 over 2, right? So I'm going to go down 1 and to the right 2. That's my rise over run, right? So from here, down 1 to the right 2. So that looks like such, like this. Now I'll put my line in there like it's supposed to be here shortly. There we go. That's close enough. All right. So these are also perpendicular. Look at their slopes. Are they opposite reciprocals? I have a 2 over 1, positive 2 over 1. You flip it, change the sign. Now it's a negative 1 over 2. All right. So there's those 4 problems. Now let's flip our page over. Go to the next page. So there's some questions here. So I want you to stop your video and I want you to answer these 3 questions, okay? Number 1, 2, and 3. Actually, just 1 and 2. Okay, just 1 and 2. And then we'll come back and we'll talk about those, okay? Answer those 2 questions. We'll come back and talk about them. Okay, so did you sketch something like I did? Hopefully you did. So it asks, what's the equation of the line perpendicular to the y-axis that goes through the point negative 4, 3? So you had to think about it, you had to picture it in your mind, or you had to sketch it. I have to sketch it because I cannot think about those things in my mind. So I drew me a little coordinate plane there. I plotted my point, and I thought, okay, what does it look like for it to be perpendicular to the y-axis? First of all, you need to know where the y-axis is, right? So this is your x-axis, this is your y-axis. This, if it's perpendicular to the y-axis, it needs to run horizontally, okay? We know that horizontal lines have 0 slope. They have an equation, y equals a number. There's your point, right? We can eliminate a and b, all right? So it crosses the y-axis at 3. So it has to be y equals 3. Your y value is 3 right here. Okay? Not too bad, right? Okay. Then the next one is what is the slope of a line that's perpendicular to the line y equals negative x minus 3? Well, if it's perpendicular, they have to have opposite reciprocal slopes, right? Okay. So if it's opposite reciprocal slopes, then that means that you have to flip it and change the sign. So if the given line has a slope of negative 1, then the new line, you have to flip that and change the sign. Now it's positive 1. Okay? You didn't really have to draw that line, did you? Okay. So now what I want you to do is I want you to look at number 3 and number 4. And just think about those. On number 3, it looks like you might have to solve for y. Number 4, you might have to just figure out what that slope is. And then, since it's perpendicular, think about what you might have to do on that one. Solve those 2, and then unpause your video and see how you did, okay? All right. So, number 3, how'd you do solving for y? That's pretty important, first of all. So you had to solve for y correctly so you could get the right slope, because the slope must be the same. So when you do, you get slope as a -1. I mean, it's not written in there, but there is. Let's assume there's a 1 there. Okay, there is a 1 in front of that, or -1 in front of that x. So the slope here is a -1, so the slope must be the same if it is parallel. Okay, so your answer would be D. Next one says determine the slope of a line that's perpendicular to the line represented in the graph. First thing you have to do is you have to find the slope using rise over run. And so that's exactly what it did. Went up 5 and to the right 2. That's this slope. Well, for it to be perpendicular, the slope must be opposite reciprocals. Right? That means flip it and change the sign. Opposite means negative. Flip it and change the sign. So I'll go from 5 over 2 to -2 over 5. I'll have to convert that to a decimal. Okay? So that's a -0.4. And if you've forgotten how to do that in the calculator, you put -2 over 5 and do Control Enter. Y'all should remember that from last year, because you do it all the time. All right. So what I want you to do is I want you to think about the two true statements about lines that are parallel, and write those complete sentences. We will talk about those in class. All right, y'all? Okay. Have a great day.